Hello guys. Start today with something good. Let's continue our journey from here. Let's see. Okay. I think today we are going to learn about the West trigger using trigonometry. So that will be quite easy for us. Let's grab that. Alright. We were here, right? This was working fine. Alright. This is
Seems useful just to reinforce the relationship. All right. Instead of using this like just the dot product result, do you want me to do that on stream, or I don't know if you want like practical examples like that. Yes. Okay.
Yeah, let's do the
Seems
practical
useful
of
just to
that.
reinforce the relationship. All right.
Trigonometry.
Okay.
So the cos of alpha will give the x component of the vector, and the sine alpha will give the y component, right?
Oh, then we can also fix the drawing of the arc. Now that we know about angles, because we had no idea what angles were before this. Okay, Unity, you need to stop rotating. You're stressing me out. It's been ticking in the background this whole time. Yeah, jeez. Should turn off the live update, because we don't need that. Okay.
Okay.
So let's go back to our turrets. Beautiful. Alright, now we have two tasks. The two things we're gonna do is that we're gonna make this one use angles instead of using just the projected value of the dot product. And we're gonna make this one just draw the arc in front of it instead of drawing the whole thing. One thing to note though is that the way we've done it right now with the with this trigger, where is my trigger? There it is. One thing to note though is that the way we've set up the angular threshold right now is actually cheaper. It's faster to do it this way than to use angles. Just as a heads up, it's not like that bad depending on how many times you're calling this function, of course. Performance always depends on how much you use them, right? Excuse me. Okay, so instead of an angular threshold, we now want to use an actual angle. I don't know if we should call it actual angle or something else, but maybe, let's see, this is the field of view, right? So let's call it field of view.
Yeah.
And this is in, let's see, do we do degrees? Probably degrees? People like degrees as an input. Oh wait, I can't write the symbol for degrees. They would make it very sad. Okay, maybe start at 45 degrees.
Yeah.
Excuse me, my throat is sad. I've been talking too much this week. Okay, now it's an actual angle. Okay, now we have some errors because things are different. We have our gizmos. And so now we actually don't have our angular threshold anymore. We just have an angle in degrees. And so somehow.
Let me see first. See if I can like understand the program first. Sorry. This one, right? This. Start at same as out 45, and this will be 1. Then, so what we were actually doing, now it's an actual angle, right? Incident ray is equal to reflected ray, which will be, if this will be, our P will be okay.
We need to be able to recover our angular threshold. And so the way our threshold worked before was like this, right? We explicitly set a the value of the threshold, and then based on that, we would check the direction to whatever it is we want to check if it's inside or outside. But now, instead of setting this one directly, we are setting the field of view, right? And the field of view is usually
would be this FOV.
There we go.
The incident ray is is equal
negative.
to reflected rays.
The field of view is usually the angle here. So it's not half the angle, it's the full angle here. So that is our field of view, right? So if this is our angle, we need to...
Let me see. Like if the FOV full, let me just check the FOV first.
figure out how
If the FOV is 45, but this triangle, the it has a basically we are actually anyway.
how long this is, right?
This is a y component, right? And actually the y component will be the same for this triangle as well and this triangle as well. If we increase the FOV like 180 degree, the y component will be 0, right? And if we decrease the FOV to 0, the y component will be 1. The height of the, sorry, the radius of the cylinder.
Right? And so we can actually use our trig functions to figure that out. So if you, let's see, I'm trying to figure out if I should make this, should rotate this or not. So one of the things we can do then is that if you imagine we cut this off here and cut our angle in half, we can use our half angle to get the length of this one. And as you can see, we're forming a triangle here. So again, we have a right angle triangle, we have half the field of view, and then we can use trig functions to get this projected value. And so I believe...
Wait. This is a p P by H or B by H? This is our X component. The P by H. This is our. For the X component, we need to find the cos, right? Cos alpha. And for the Y component, we need sine alpha.
Leave, all we need to do is do the cosine of that half angle to get this, the length of this one, which was our old value P. So we can make a property for that. Angular threshold. So I believe that is the cosine of our field of view.
Field of view.
And then we convert that to radians.
Yeah.
And then we divide it by 2 because we want half of the angle, not the full.
Yeah, half of the angle.
Full angle. So I think this is correct. I could be wrong. So let's see if this works. Okay, so I think that might be correct. Yeah. So we can set it to 45 degrees. You can see that this is a 45-degree angle. We can set it to 90 degrees, and we now have a 90-degree angle.
Okay, it's working fine. Yeah. I really like this one. It's lovely. All right. First, let me select my electives for my college. It's okay. I have to do the pre-registration session. All right. Assist. Which one it is this one? Automata. Okay. Okay, 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 okay. Okay, okay, okay. All right. Automata done. Computer organization and architecture. All right. I really don't want to do that, but there's no option. I really don't like this professor. He's very arrogant. Alright, this thing is done finally. This is my core subjects. Okay. I really want to go with the human rights. Right. This is the machine learning, and this is data mining. Okay, this is done. This has been done, and now we can continue. Just about right. Let me just understand this one. Okay. And I want to write it as well so I can understand. You know what? I really need a coffee though. Time it is 30 minutes. Let's take a break. 15 minutes in 45, 1 hour. I think that would be good. What we were doing? FOV, right? This is a minus x, and this is our plus x. This is our p, which is y coordinate. This is our FOV. So the code will be very simple. It's very simple. changes. Just make a range of 0 to 180. So P equal to, we have done right, P equal to P equal to cos function equal to this. Okay. This is done.
So this,
Okay.
which was our
Now we
old,
can continue.
that to. So I think this is correct. I could be wrong. So let's see if this works. Okay, so I think that might be correct. Yeah. So we can set it to 45 degrees. You can see that this is a 45-degree angle. We can set it to 90 degrees, and we now have a 90-degree angle. And we can increase it all the way to 180 degrees. And so there we go. We converted it to angles instead. Okay. Any questions? Sorry for the messy scribbles. It got kind of tight in here. What was the other thing we were gonna fix? Oh yeah, the arc. Where we're gonna do that. Typing, typing. Yes, we're gonna do only the slice now. Alright. So now that we know the angle, I guess maybe we can do... We're gonna need the field of view in radians, so might as well make a property for that too. I like properties, they're very useful. Okay, so the gizmos, previously we were using the disk. So these are the ones that are drawing the full like circles on top and at the bottom. And so we want to draw the partial arcs of this. So we need handles dot draw wire arc. Okay. So let's see. So
what did I miss?
I like properties. They're
Give me a second.
instead. Okay.
Okay. This was fine.
Any questions? Sorry for the messy scribbles. It got kind of tight in here. What was the other thing we were gonna fix? Oh yeah, the arc. Where we're gonna do that. Typing. Yes, we're gonna do only the slice now. All right. So now that we know the angle, I guess maybe we can do... We're gonna need the field of view in radians, so might as well make a property for that too. I like properties, they're very useful. Okay, so
These are actually not a function. These are actually properties. It's difference. It's not a property. So
the gizmos, previously we were using the disk. So these are the ones that are drawing the full like circles on top and at the bottom. And so we want to draw the partial arcs of this. So we need handles dot draw wire arc. Okay. So let. Let's see, we have a center, we have a normal, we have a from, which I'm guessing is the start of the arc. And then we have an angle, and then we have a radius. Alright, so we are in local space here. And so the center is just going to be 0. The normal is just going to be up.
Vector dot up.
The start direction, I believe, is going to be V left. No, sorry, V right. No. V left. So we're gonna move these because we need access to our vector. So V left is the this vector right here. In local space, the direction that that's pointing. I don't know if we need to normalize it. I don't know if the wire arc does that automatically. And then the angle, I don't know. This is actually in degrees. Okay, so Unity is using degrees here. Always good to look it up. If your function is using Unity is using degrees here. Always good to look it up.
Really? Then why we actually done the bits in degrees?
And then the angle, I don't know. This is actually in degrees. Okay. So Unity is using degrees here. Always good to look it up if your function is using degrees or radians. Ideally, all functions would use radians, in my opinion, but unfortunately, Unity is mixed. It's using both radians and degrees very inconsistently all over the library. For instance, angular velocity in 2D is using degrees, but angular velocity in 3D uses radians. Because fuck it, you know? Who cares? It's just nothing is consistent and everything is garbage. And so you just have to get used to that and read the documentation all the time.
Right.
Anyway, so we want to pass our field of view in degrees into this one. And then we need the radius, and that's just radius. And I believe that should do the bottom of that pie, and then we need to do the same thing at the top.
From B left, B right.
Okay. And then let's recompile, see if this works. We did it! Look at this beautiful, beautiful trigger. Isn't this the best cheese wedge you've ever seen? It's great. Okay. All right. It's actually pretty satisfying to see. I know, right? It's really nice. Like once you see this nice little convex nugget, you're just like, yes, you just want to eat it. Okay. If you want the code, then here you go. How would you go about doing this in game view, line renderer? Yes, kind of. Sort of. The thing is, Unity doesn't actually have good tools for doing this in the game view. You can enable gizmos in the game view if you want to, but this is not going to show up in builds. So if you want to draw lines that show up in builds, then generally you would need either a third-party plugin for that, or you can draw shitty lines using gl.lines, and then you can push vertices to that, and like very manually draw lines using those. But they are always 1 pixel thick, and they look kind of garbage. But if you want a library to draw vector graphics, wow, imagine that. Then someone made a plugin called Shapes, which I very much would recommend if you want to draw vector graphics in Unity, like lines
Really?
or arcs or circles.
Damn. No, she made it. Damn. It's so cool.
Want a library to draw vector graphics. Wow, imagine that. Then someone made a plugin called Shapes, which I very much would recommend if you want to draw vector graphics in Unity, like lines or arcs or circles. So there you go. But otherwise, built in Unity, you would use a line renderer or GL lines, basically, if you're not using anything third-party. Or make your own, like, shaders for that. But it's a lot of work sometimes, at least if you wanted to support a lot of features. Yeah. Okay. You know what? We should do our 10-minute break. So
Okay.
I'm actually gonna show you what Shapes looks like. So you can get a sense of what it does.
Yeah, I really want to watch
So
what it does.
in case you didn't know, I've been working on videos for YouTube for a while. Like educational math videos.
Yeah.
And I make those videos in Unity.
Really?
And so I made a custom timeline tool to make animations, and I have made a vector graphics library to draw these things. And so it's kind of like a janky video editor, except it's in Unity. And then all of this stuff is drawn using Shapes and Text Mesh Pro. That's basically all I use throughout this entire video. So this start of the video is just explaining lerp, which I've already explained before. Yeah, and so this is my little video editing tool.
Linear interpolations.
And you can sort of scrub to any moment in this whole timeline. It is a very long video, and full of shiny animations and whatnot. But yeah, so this is a custom timeline. This is not Unity's timeline. This is completely unrelated to that. So it's a custom tool made specifically for making these animations. And so if you're wondering,
Cool.
how do I draw lines in Unity? What I do is that I use shapes, which allows you to just draw lines, and it works in like in game as well. It's not editor only. It's just that I just do all of this in editor because it's convenient. Again, on draw gizmos is very nice, and so I do a similar thing for this. Yeah, and so that's splines, and yes, this is the spline video that I'm working on for so long. It is about an hour long. But yeah. Look at the splines go. So this is using splines for animations. Classic use case for splines. Is shapes vector or SDFs? I don't know what you mean by vector in that case. You can make vector graphics using SDFs, which is what I'm using in shapes. I use SDFs in many different places. But it's kind of the 2D SDFs. It's not the ray tracing type of SDFs. Because SDF is kind of a popularized term that means a little bit too many things now. But under some definitions, then yes, I'm using SDFs. Okay, so yeah, that's how you draw lines in Unity. Will you ever publish the tool? The timeline is only for me. I don't have any plans on publishing it. It is a hack. It is just leaking memory. It's just awful. But it's good for my use case because I'm just rendering a video using this, right? And so I don't have to care about memory leaks. Anyway, this is the outro of the video. Quick shout outs to NURBS, because I didn't have time to elaborate too much on NURBS. And did you know that the color gradients are just splines in RGB space? So if you draw the RGB cube, that's a gradient right there. So if you're doing a gradient map in Photoshop, then that's just a spline. It's a spline in color space. Isn't that neat? I think that's super neat. I think it's cute. Okay. Anyway, credits. I'm not done with the credits. I need titles for these. But anyway, can you teach us to make a timeline like that? That is gonna be a thing for your tool development course. So not a thing for this course. Okay. All right. Were we gonna do a 10-minute break? I don't know when we're supposed to start. Do we start at 15:05 or I don't know? Yeah, I don't know if it's a good thing to have an assignment to make a timeline like this, because this took a very long time. Splines. Imagine that. Okay, yeah, let's do a break until 15:10.
it has a X component right there, Y component right here, and the Z component you can see from here to here. You can see there's a so yeah, it's a 3D line. Damn. Damn. The memory leaks are insane. I mean, this is how you can see like how your ratings can go from very good to very low because of some typical bugs. So the bugs are really important to fix first before you actually post, because the memory leaks and everything will actually destroy your asset. So tool development, we actually see into the tool develop. Oh my god, see also, damn. C is the best, bro. I mean, for the covers and everything, C is the best.
Is there anything that you would like me to go through in terms of tools that I might miss? Because otherwise, I'm going to talk about like things that I think is good. But if you have like specific things that you might want me to cover, then do let me know, because they would be really useful. I think someone was asking, like, what is expected of a tool developer as opposed to a like gameplay programmer, or a regular programmer, whatever that is at a game studio. So, I mean, a tool developer in general is not really going to work on the code that's in the game, but rather work on the code that's for the developers, to assist the developer.
Yeah, I learned about.
Seems useful just to reinforce the relationship. All right. Okay. Oh, then we can also fix the drawing of the arc. Now that we know about angles, because we had no idea what angles were before this. Okay, Unity, you need to stop rotating. You're stressing me out.
Oh, there.
This is a nice little con start.
So we also take a break. We should
Yeah, I
probably
don't know if it's a
take a break.
good thing to have an assignment.
Alright, 10 minutes break. I mean, we can continue from. I think I'll take 15 minutes break because I need to make some coffee as well. I need to go wash him. Guys, I'm back. Let's continue. Okay.
To make a timeline like this, because this took a very long time. Splines. Imagine that.
Yeah.
Okay, yeah, let's do a break until 15:10. Yep. But for my okay, I'll be right back.
Then rest break, right? I'll also drink my coffee till then. All right. Two hours, 4 minutes. Break will end,
Oh,
and
sorry.
then
Yes, I
we'll
muted.
start the rotation.
I forgot what I was saying. Oh yeah, so salad is like 5.3 kilograms, and he's 8 months old, and so he's not very old yet. So I think he's gonna grow up to be a big boy. And he's already kind of big. But there's a people say TM on the internet that it's actually impossible to overfeed kittens. So according to the internet, he shouldn't be overweight. So apparently he can't be overweight. He's supposed to only be overweight if he's older than 1 year. So when he's an adult, I imagine he's gonna immediately become overweight, or maybe not. We'll see. Okay, some shit happened in the kitchen. I'm just gonna go check that out. It's hard to tell if salad is fat or fluffy. Yes. To all three. Yes, it's hard to tell. Yes, he's fat. Yes, he's fluffy. So I think it's a combination of everything, but also hard to tell. Okay, all right. I believe this is the final stretch, right? This is the last break. I think, according to, I forget what our schedule is. Where's my calendar? Yeah. All right. This is the last bit. We didn't actually have time to talk about a few things, but we could do that next week. So we actually have a few things I want to do next week. So that's good. All right. I have been a little bit more wordy today than I usually am, or during this course, than with the previous students. I think. I forget how I set up the other courses. I am very unstructured in my teaching. I don't have exact notes that I'm following or anything. For better, for worse. Is the stream lagging? Is it? Is it lagging for people? Everyone reacting with an Internet Explorer makes it look like it's lagging for everyone. But, okay, it doesn't lag for people. Alright. Okay, just you. Alright. Thor? Hey? What? Okay, Thor has opinions. That's okay. Final bit, let's go. We are finally going to talk about rotations. Okay. Oh boy. How do we approach this? So, in 2 dimensions, rotations are pretty straightforward. There are some, there are a few different ways we can represent a rotation in 2D. We can either do it using an angle, right? We can just have a single number that represents a rotation, because if it's just 2 dimensions, all it takes is one number for us to represent a rotation. And when we talk about units, like I mentioned before, units are always relative to some zero, some center point, right? Some identity value. And angles is usually an angular measurement that deviates from the x-axis, right? So an angle of some value, right? What that means is a positive rotation that rotates it away from the x-axis. And so angles is just one way we can measure things in 2D, or store rotations in 2D. Another way we can store rotations is using basis vectors.
Oh my god. Back. Yeah. Let's go with the rotation part now.
That's okay. Final bit. Let's go.
I'll also drink my coffee because I'm quite sleepy.
We are finally going to
now.
talk about rotations. Okay.
Give me a second. Just a second. My phone. Mm, okay. I don't have class tomorrow. And PKT. Right. This is the break. PVB 11 a.m. Alright. We'll go to the PVB one. Then RVS. I think I'll do it when I wake up because I don't have the, you know.
Oh boy. How do we approach this?
It's already 1
So,
hour 45
in
minutes and we haven't
two
done
dimensions,
anything very
rotations are
serious.
pretty straightforward. There are some there are a few different ways we can represent a rotation in 2D. We can either do it using an angle, right? We can just have a single number that represents a rotation. Because if it's just 2 dimensions, all it takes is one number for us to represent a rotation. And when we talk about units, like I mentioned before, units are always relative to some zero, some center point, right? Some identity value. And angles is usually an angular measurement that deviates from the x-axis, right? So an angle of some value, right? What that means is a positive rotation that rotates it away from the x-axis. And so angles is just one way we can measure things in 2D, or store rotations in 2D. Another way we can store rotations is using basis vectors. We've already done this. So in 3D, we were storing basis vectors in a matrix, right? We have the x direction and the y direction, and then we can store that and then
yeah, GitHub, I think. It's on GitHub. Yeah. Perhaps the lecture note will be in GitHub. I actually follows her in GitHub as well. This one. Or this one. She don't do much work these days. Look at her. Sad actually. She has to work a lot, I think. 2025, she haven't done anything much. This is where I made it at 2023 on October 9th, 2023. I remember these were actually when I was in first year of my college, and I was so bad at studies and everything. I just used to play video games and everything. Didn't have done anything much. Then in 2024, this is how was my progress look like in 2024. Well, in 2025, I haven't done anything much, but in April, I started actually studying, right? Save the game, yeah, this game. Save the circle. In 2025, started these. I actually started it from April, but these logs were actually deleted by me because of some mistakes. So that's why you can't see these logs. But yeah, there was. So from May, I was very consistent. Yeah, these were like some days. I actually didn't missed. It was actually a bit mistake, like for the commit mistake, because I used to study very late after 12 a.m. So that's why you can see a lot of contribution in next day, but you cannot see before that. So that's how there was a lot of consistency. I think the consistency is the key. I've done a lot of programming work, lot of practices. If you want to see some of my old program codes, mm, yeah, these files show you in the new window. Also, these are all everything I've practiced these days in the C program. Sorry, C++. I used to practice it in the class, all the concatenate and everything. I used to practice. These were not very structured, to be honest. I learned but I used to practice object-oriented programming every day. And there was a professor in my college. He actually helped me a lot to learn and to learn C++. And he was just really good professor who actually helped me to overcome my fear for the programming. He helped me a lot. I'll never forget him. And look at this. It's I mean, I can just remove all this and I can just include bits. It was bits 32, I guess, something like that for the algorithm dates slash STL for the STL library. Damn, this was so nostalgic. Nostalgic. I mean,
And from that, that describes an orientation, right? And so we can also describe orientation in 2D using vectors. Um, so we can have it in vector form. And this would also describe an orientation because, again, this is a deviation from the x-axis.
I think I'll just sleep tonight because I'm
Okay,
very sleepy.
that's all well and good. But in 3D,
We'll continue the
things get
rotation tomorrow.
quite a bit more complicated. In 3D, if we want to store an orientation, the way that I'd like you to think about orientations is in terms of the basis vectors. So in Unity, we would have y up as our default. And then we have our
Guys,
three
I think this will be it for today. Then we can continue it from tomorrow, the rotation part, because even if I learn today, it won't help us actually. Because I'm sleepy and I cannot understand what she is saying. Cannot understand the concept. So that's why let's do it tomorrow because I'm quite sleepy. Let's just see our some logs. These audio listeners are very important. I still remember like I deleted these and I couldn't add the audio in my previous games.
Just put out a bounty for the world.
Can you just
She's really, really talented. All right, let's save everything and make a log. Okay, guys, I think this is it. We'll see you tomorrow, right?